correlation, and it's a correlation coefficient just like Pearson's correlation coefficient, except that it gives you a number ranging from -1 to +1 that indicates how strongly two sets of ranks are correlated, very similar to Pearson's rank correlation or Pearson's correlation coefficient. So what we're going to do is we're going to do a practice question and prove Spearman's rank correlation, and this is going to be student ranks in math and science. So we're going to write a Python program, and in order to execute the program, we're going to need to import 3 libraries. And the 3 libraries that we're going to import are NumPy as NP, which is for the numeric library, and SciPy.stats imports Spearman R, and Spearman R is going to be for Spearman's rank correlation function. Stats is the statistical module in the SciPy library, and SciPy is a scientific library. And we're going to import matplotlib.pyplot as PLT, which is for visualization. So now we're going to set up some mathematical example data, student ranks in 2 subjects of math and science. So you're going to have math ranks, which are going to be numbers from 1 to 10, and then you're going to have science ranks, which are going to be numbers from 1 to 10, but in a different order. And then we're going to calculate Spearman's rank correlation coefficient, Spearman coefficient, comma, p-value, and p-value is a probability, equals Spearman R, brackets, math ranks, comma, science ranks. And so we're going to print the results of Spearman's rank correlation coefficient and the p-value. So we've got the results right here. So Spearman's rank correlation coefficient is 0.94. That means it has a very high correlation. And the p-value is 0.0001, which means it is less than 0.05, which means that the null hypothesis would be rejected. And the positive correlation, as ranks in one subject improve, ranks in the other subject tend to improve as well. So if Spearman coefficient is greater than 0, then it's a positive correlation. If Spearman's coefficient is less than 0, it's a negative correlation. Else, there's no correlation. So the Spearman's correlation coefficient is greater than 0, so it's got a positive correlation. As ranks in one subject improve, ranks in the other subject tend to improve as well. So now we're going to visualize the data. So plt.figure, brackets, fig size equals 6, 4. We're going to create a scatter plot. plt.scatter, brackets, math ranks, comma, science ranks, comma, color equals blue, comma, label equals rank data. And then we're going to plot the math ranks. So plt.plot, brackets, math ranks, comma, np.poly1d, brackets, np.polyfit, brackets, math ranks, comma, science ranks, comma, 1, brackets, math ranks, comma, color equals red, comma, label equals trend line. Now we're going to add labels and title to the graph. The title is Spearman's rank correlation, math versus science ranks. X label is math ranks. Y label is science ranks. And you get a legend and you get a grid. So this is the chart that is created with the Spearman rank correlation, math versus science ranks. So you can see that on the x-axis you have the math ranks, and on the y-axis you have the science ranks, and you can see that it makes a very good symmetrical graph, which is why you get a spearman's rank correlation of 0.94, which is almost 1, so it's almost a positive correlation. So that concludes this video on spearman's rank correlation. And the next video we're going to make is going to be on simple linear regression. So I hope that you decide to watch it. Thank you for watching.